Hello, Algebra 2 students. Mrs. Allison here. Today we're going to look at the quadratic formula, but with imaginary solutions. So first, if we recall, a zero or a solution is whenever it crosses the x-axis. So if I want to draw a quadratic, which would be a parabola or a U-shaped graph, with two real zeros, I would just have to make sure that parabola crosses the x-axis at two different points. So this would be an example of a quadratic with two real solutions. One real solution, it would cross at one point or touch, or what we would call a double root. So it would bounce off the x-axis and touch at one spot. Now, zero real solutions would be a quadratic that would never touch the x-axis. So these are all examples, and remember our parabola can open up or down of two real solutions, one or zero. So we've been practicing solving for these solutions using quadratic formula. So let's take a look here at this example. So remember, I'm going to identify A, B, and C to plug into my quadratic formula. So here my A would be 1, my B would be -3, and my C would be 10. And if we forget our quadratic formula, I have it written right over here. So it's going to be x equals -b, so it's going to become +3, plus or minus the square root, -3 squared, remember I'm going to put that in parentheses because I want +9, not -9, minus 4ac all over 2 times a. Okay, so then I'm going to simplify under the radical first. So I'm going to figure out what this number is under the radical. So that would give me 9 minus 40, which is -31. Okay, 9 minus 40 would give me -31 over 2. Now back in Algebra 1, whenever you got a negative under the radical, you would say no real solution, and you would stop. What that means is that there are actually solutions, you just can't see them. Kind of like in this graph over here. When my parabola never touched the x-axis, I can't see those solutions. So what we call those solutions, we call them imaginary. Okay, we can still solve for them, but they're imaginary. So to do that, we have to introduce a letter, and that letter is I. Think of imaginary I. And I represents the square root of -1. So therefore, anytime I have a negative under my radical, I can actually simplify. I just have to make sure I put an I in my answer. So if we go back to our example here, I can take out that negative and put an I in my answer. So it would be 3 plus or minus, I goes outside. I can't simplify the square root of 31 over 2. And those would be my two solutions there. Okay, the I represents that they're imaginary. You cannot see them on the graph. So therefore, I would have two solutions with an I in there for imaginary. So let's kind of take a look here and simplify some of these square roots with negatives in them. Okay, so if we think about this, the square root of 4 is 2. Okay, the square root of 4 is 2. And because I have a negative under my radical, I'm going to put an I in my answer. So my answer would be 2i. Okay, let's talk about the square root of -3. I can't break down the square root of 3. That's as simplified as it goes. However, because of that negative, I can pull an I out front of my radical, and the 3 will stay under. Okay, let's look at the square root of -12. I can break down 12 into the square root of 4 times the square root of 3. The square root of 4 is 2, so that would go outside of the radical. Okay, when I take the square root of 4, that becomes 2, that goes outside. So that's going to go outside of the radical. Because I have a negative, that will also go outside as an I. And then the square root of 3 here, okay, we didn't break down the square root of 3, stays under the radical. Okay, so let's take a look here, and we're going to practice solving. Still using quadratic formula, but now we could have I's in our answer, imaginary solutions. So if we take a look at this first equation here, we're going to identify A, B, and C. Now if we notice, we don't have an x term. So I could rewrite this as x squared plus 0x plus 16. Okay, and I could try to factor this. However, it is not factorable because there's no factors of 16 that is going to give me 0. 4 times 4 gives me 16, but those adds give me 8. Okay, so I'm going to plug in the quadratic formula where my a is 1, my b is 0, and my c is 16. I'm going to say x equals negative 0 would just be 0, plus or minus the square root of 0 squared minus 4ac all over 2a. Okay, then I will simplify here, and I'm going to take 0 plus or minus the square root. I'm going to figure out what this number is under the radical. So 0 squared is 0. Minus 4 times 1 times 16 is negative 64 over 2. So now I'm going to look at simplifying my square root. Okay, the square root of negative 64, I know I can pull out an I because of the negative here. And the square root of 64 is 8. So I have 8i. Okay, so when I simplify this, I would get x equals 0 plus or minus 8i over 2. Or 0 plus or minus 8i would just be plus or minus 8i over 2, which simplifies down into plus or minus 4i if I divide those. So my two solutions here would be positive 4i and negative 4i, which once again are imaginary. You would not see those values, your parabola across the x-axis. Okay, last one here. I wanted to make sure I point out to you that in this case, you should notice that a is actually negative 1. B is negative 2, and C is negative 4. So when I plug into quadratic formula, I'm going to say x equals negative b is going to become positive 2 plus or minus the square root of negative 2 squared minus 4ac all over 2a. Okay, so then I'm going to simplify under my radical first. Okay, and I can use a calculator for that if you want to, if you're not sure what it is. So if I type in my calculator negative 2 squared, that should give you 4. Okay, so I want 4 minus, and then 4 times negative 1 times negative 4 is going to give me 16. So 4 minus 16 is negative 12. So I have x equals 2 plus or minus the square root of negative 12 over negative 2. So then I want to simplify this negative 12 and break down my radical, okay, which we already did earlier. But just to quickly review here, that negative is going to come out front as an I, and I can break down 12 into the square root of 4 times the square root of 3. The square root of 4 is 2. So when I simplify that, I'm going to have 2i square root 3. 2i, because I pulled out the I, and the square root of 4 is 2, and then I still have the 3 under the radical, over negative 2. Last thing I want to do is I'm going to actually simplify each of these numbers here. They are all divisible by 2, or even you could do negative 2 if you wanted to. So when I do that, I end up with 1 plus or minus 1i, or just I, square root of 3 over negative 1. The other option is I could say negative 1 plus or minus I over square root of 3 over 1. Or you don't even have to put it over 1. Okay, so I could just do negative 1 plus or minus I square root of 3. Either answer is acceptable there. You can either leave the negative on the bottom, or you could actually divide both terms by the negative to get rid of the negative in the bottom. Okay, so you're going to practice now the quadratics practice with imaginary solutions. So you should end up with i's in your answer because those solutions don't actually exist on the coordinate plane. Have a good day.